Welcome back, and if you recall in the first video I demonstrated how we could create the symbolic uh, output in the time domain using the Laplace transform which of the output, which we obtained by multiplying the Laplace transform of the input uh, by the transfer function. Let me just comment this. And let me comment this one. That's our transfer function. And now I want to show how you can plot this using Matlab, plot the symbolic functions using Matlab. I'm going to create a section break. And I can clear out this window, clear all output out. And all these variables that we calculated in the first one should still be in memory. If not, just run that section. And the first thing I want to do is I want to create a range of values, and I'm going to call it T range. It's going to tell us where we want to plot from. I have to know a little bit about what I expect to see. This is a RC circuit with an input step, and I should see the capacitor charge up and hit a steady state value in about 5 time constants. And if you recall, our time constants our time constant tau was equal to 5 milliseconds. So I want to make our range go from 0, let me put an equal sign in here, 0 seconds to 5 milliseconds, and I'm going to do it in increments of 1 microsecond. So this is there's going to be 5,000 data points, e minus 6, and 5 times tau. There's going to be 5,000 data points to capture this. The other way I could do this is I could say, boy, I'd like to do this as tau divided by 1,000. And so for every time constant, we'll use maybe 100. I'll do 500 data points instead. That should be sufficient enough. And that'll create a range of points that represent times, 0, 10 microseconds, 20 microseconds, so on and so forth, all the way up to 5 milliseconds. And I'm going to put the semicolon. The semicolon suppresses the output, so I will not see the output over in our output window on this side. So that's our range of time. And then the functional call to plot this is plot, and we want to put our x-axis, which will be t range, and then our y-axis will be small case v, and we're going to evaluate it over that range of time, t range. And this should provide us with a nice plot of our output. And let me run the section. And sure enough, you see we have this nice exponential charging up of the capacitor up to 5 volts, because our input was a step of 5 volts. There's our input function. It was a step 5 volts, and the output of the capacitor voltage across that cap charges up to 5 volts as well, and it takes about 5 time constants, 5 milliseconds. I want to make this plot more presentable, so there's a couple things I'm going to do. X label, and that's going to allow me to label the horizontal axis, which is time, and I'm going to put our independent variable t, and I'm going to put the units of t, which is seconds. And if I run that, you'll see it change the plot. Sure enough, there's time in seconds. And I want to put a label on our y-axis. That is our output. And it has the units of volts. So I'm going to put the units of volts in there. Let's run that section. Again, you should see the y-axis populate. Sure enough, it does. Perhaps sometimes you want to put a grid overlaying, so you can turn the grid on. And you can't really see it too well here. Oh, hold on, I didn't run it yet. That's why. Go back and run the section. But you can't see it too well. But one of the things I can do, if I click on here, I can actually open the figure in its own window. And we can work on it in here as well. And here's the figure in its own window. Let me expand this out a little bit. And you can now see that the grid has been turned on. The one last thing I do want to do, I'm going to close that up, is I want to put a title on it. And let's call this step response of RC circuit. And that will put a title on there. Let's run this section. And there we have our graph is all set. And again, I can pull it out by clicking up, open the figure in window. I've got two screens up. You can't see the second screen. I just pulled that into my main screen that I'm doing the video capture on them. And we can now cut and paste this, copy it, and put it into your report or wherever you need to do with it. And we can. There is more control on how to set this up. You can use it to find out different values of the points, like a cursor for a scope. So all sorts of things we can do in Matlab once we have that plot. So I hope this video helped you with how we can generate using symbolic tools within Matlab in a live script and generate a plot. If you're, I encourage you, go ahead and use this to help with your homework. Check your values in your homework assignments. If you are going to turn this in directly, make sure you put comments in your script code, and so I can follow to see what's going on, the steps you're taking in your code. And you know, more than welcome to submit this as for your homework, and using this as a nice tool to help with your homework. Thanks for watching.